Good morning, everyone. Welcome to the Impact of Recent Rain on Water Resources in the Murray-Darling Basin webinar. For those joining us for the first time, welcome. And for anyone who has joined us for our webinars before, welcome back. Today we'll be reviewing the drought conditions in the Murray-Darling Basin over the last 3 years and also look to the changes the rains in 2020 have brought to water resources. My name is Jordan and I will be your moderator today. I'm joined by Claire, who will be producing today's webinar. Together, we will make this webinar as interactive as possible, but before I start, may we ask for your attention as we cover off some housekeeping items. With the current situation as it is in Australia, this webinar will be conducted from our respective homes. Please bear this in mind as we may encounter some technical issues during the broadcast. Our broadcast today will run for 60 minutes with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time attendees, please see the helpful tips on your screen. Most importantly, please note the chat box, where you can send through any questions or feedback for the presenters. Please use this and not the Q&A box to send your questions to us during the session, and we will answer as many as possible during the allocated breaks. If you're having trouble finding it, it's the little speech bubble button in the taskbar on your screen. The icon will turn blue once it's on and send to all panelists so we can see it. If you want to test out the chat box now, feel free to tell us your name and where you're dialing in from. And I can see some people have already done that. In response to feedback received from previous webinars, here is some information on how to participate in our polls. When a poll is in motion, attendees will see a set of questions to the right on their webinar screen. Please select your answer, followed by the submit button below them. I'll also take this moment to thank those of you who sent in your questions during your registration process. We've developed the content of this session in accordance with those common themes of those questions. We had a big debate about it just before we started, actually, so thank you for engaging with us. And finally, I'm delighted to introduce you to our presenters, Dr. Alison Oake and Daniel Burton. Hi, guys.
Morning, Jordan.
So, Dr. Alison Oake is a hydrologist with a focus on the state of water resources in Australia and their response to short and long-term changes in climate. Daniel is also a hydrologist with nearly 20 years' experience. His role at the Bureau is focused on ensuring decision makers in the Australian water sector, and I'm sure there's plenty of them out there, are supported by the best information, analysis, insight, and data from the Bureau. So you have the two perfect experts to talk to us today. Hey guys, Alison, would you like to take us through what we'll be hearing about today?
Yeah, thanks, Jordan. Today we're going to run through and tell the tale of two summers in the Murray-Darling Basin. In the past 6 months, we've gone from the very depths of one of the most severe droughts on record to a situation where areas are being flooded and the landscape is starting to turn green. So first, Daniel's just going to run us through where we got to this summer, so how dry it really got in the Murray-Darling Basin at the beginning of the summer, with a focus on the water resources and the impact on the communities that depend upon them. And then I'll look at the significance of the rain since January and how much impact it's actually had on the water situation in the Murray-Darling Basin. So where we've seen recovery and where we haven't seen so much. But before that, Jordan, I understand you have a poll for us.
Yeah, we'd like to find out a little bit more about what your relationship to water is. So our first poll will be turning up on the right side of your screen now. It's what water-dependent decisions will you be making in the upcoming months? Will it be for agriculture? That's A. B, emergency management. C, water resources management. Or D, other. And as you get those questions, those poll results in, we do have a few questions that have come through. Angus would like to know, how do you determine if a catchment is saturated? Alison, I think you're the best person to ask about that.
Yeah, thanks, Angus, for the question. There are a lot of different ways you can determine if a catchment is saturated. If you're out in the field, you can dig a hole and look at the soil. But here at the Bureau, we like to do it on a much wider scale, and we're looking at soil moisture and how it varies across the whole country. So we use a model called the Australian Water, Australian Water Assessment Model that We have soil properties within that model that vary right across the country, and they have infiltration rates, and we look at how much rain falls, which we can measure, and we look at how it infiltrates into the soil, how much of it runs off, what the water holding capacity of that soil is. And once it reaches that, based on our modelling, we know that the catchment is saturated.
Okay. We are getting a lot of questions that have been coming in, and if you've got one, please feel free to put it in the chat now, and we will get to it as soon as we can. A lot of people are asking us to kind of look into the crystal ball and tell us what the rainfall total will be in this area for the next 6 months. When is this water going to reach here? We're not really able to do that with immense accuracy, but there are some resources on our website. Would you like to go through and tell people where they can find out more information if they want to know stuff like that?
Yeah, so our climate outlooks, which we'll run through in this presentation towards the end, can give you an idea of the chance of above average rainfall going forward in the next 3 months. But it can now, as part of the new service, it will actually give you the chance of what millimetres rainfall you'll get for the next 4 weeks for any location in Australia. So that's a great new service the Bureau is offering. There's also the stream flow forecast. We'll run through some of these and point you to them in the presentation, so don't worry about writing them down at the moment. We've also got the flood forecasting that will give you an idea if there's any dangerous floodwater heading your way. But let's get going, and then you can see some of those things in action.
All right, so if you've put in your poll question, now's the time to jump up, grab your pen and paper, come back, because there's going to be plenty of usable information during this webinar. David would like to know, what is the range of water salinities in the Murray-Darling system?
Oh, that's a great question, because that salinity can vary a lot across the basin, depending on whether you're talking about groundwater or surface water, but I'm going to assume he's talking about surface water there. So most of the surface water in the Murray-Darling Basin is fresh, so below 500 milligrams per litre of total dissolved solids. But there are areas, especially when water gets low, that do get up as high as being saline. Areas through the Upper Darling, as you would have seen when they got very dry during the drought, got quite saline. And there's some areas through the Murrumbidgee that can be quite saline at points. So we're talking sort of upwards of 10,000 milligrams per litre. So quite saline at points, but the vast majority of sites that we measure salinity in the Murray-Darling Basin do register as fresh, and you can see that on the monthly water update, and also our data. If you want the raw data for that, you can get that from Water Data Online, which we point you to later on.
Okay, well, plenty of interesting tidbits there. If you want to get in a question that you'd like answered, these are two excellent hydrologists waiting to take your questions, so start sending them in now, and we'll get to them in our next question and answer session. But the results of our poll are in. Most people are going to be making water resource management decisions in the upcoming months. So thank you for participating in that. As I said, more questions and another poll will be coming later up, but we're going to kick it off with Alison. You're going to, sorry, Daniel, you're going to start us off by talking about recent conditions in the Murray-Darling Basin.
I am. Thanks, Jordan. I'm going to talk today about how recent drought has affected water resources. And by water resources, I mean the availability of water in soils, dams, streams, and groundwater. I'm going to look at the drought from a water resources perspective and talk about the 3-year period from January 2017 to December 2019. After this point, we start seeing more consistent monthly rainfall across the basin. Storages started receiving inflows, and many dry rivers started flowing again. This doesn't mean the drought is over, but it seems like a natural period to discuss how the drought impacted water resources in the basin. Now, comparing droughts is difficult to do, as they can vary in size, intensity, and duration. But what we can measure is how hot and dry the last 3 years got compared to our climate record. Coming up are animations that show monthly rainfall and maximum temperature deciles from January 2017 through to December 2019. The deciles compare each time step from 1 month to 36 months to all other such periods going back to the turn of the century. The rainfall deciles map shows that large areas of the basin recorded very much below average to the lowest rainfall on record. And this is particularly evident through the north in 2019. Now on the right-hand side is the maximum temperature map, and this moves at the same time step as the rainfall, so you can compare them side by side. And what really spoke to me was how much of the basin experienced the highest temperatures on record through 2019. And this was pretty much the entire basin. And what this shows is that by December 2019, temperatures across the entire basin were at a near record for any 3-year period going back to 1910. It also shows that the 3-year period was the hottest on record for the entire central and northern Murray-Darling Basin, and rainfall was the lowest on record for much of the same area. In response to the hot and dry conditions, large areas saw the lowest soil moisture on record. On the left, we're looking at the deciles for root zone soil moisture, which represents the top 1 metre of soil. The large areas of dark red show that the period through 2017 to 2019 was the driest 36-month period in over 100 years. And this is particularly evident along the east, where generally most of the rain in the basin falls. The map on the right shows the same period recorded the highest potential evapotranspiration rates on record, and again, particularly in the north. The very high evapotranspiration demand would have resulted in high rates of evaporation of water that remained in storages or in rivers. The record dry soils and potential evapotranspiration rates provide us with an indication of the moisture stress experienced by vegetation and the severity of the agricultural drought, which by the end of 2019 it had been going on for 3 years in some areas. Unsurprisingly, these hot and dry conditions had a significant impact on farmers. And the picture on your screen is actually from my manager's parents' farm, which is on the Queensland-New South Wales border, and it shows just how much change there was in 1 year. From January 2017 to December 2019, we saw record low soil moisture levels in parts of the basin. And this combined with rainfall deficits that were especially concentrated in the cooler seasons, limiting the soil moisture available for the summer growing seasons. As a result, ABARES, the Australian Bureau of Agricultural and Resource Economics and Sciences, estimated that the area of planted crops during the 2019 to 20 summer growing season decreased by 2/3 compared to the previous year. Dryland farming relies on regular, predictable rainfall to maintain enough soil moisture to grow crops, and the impacts of drought are often felt on a year-by-year scale. A few months of above-average rainfall, as we saw in early 2020, can quickly replenish soil moisture stores and support a quick resumption of farming activities. However, not all water resources can bounce back so quickly. The map on the right shows the major water storages of the Murray-Darling Basin. These are publicly owned dams that have a capacity greater than 1 gigalitre, which is 1 billion litres. As you can see, water storages reached critically low levels in the northern basin at the end of last year, with many, particularly in the north, running at a handful of percent of capacity. And after consistently decreasing for 3 years, the total storage in the northern basin reached only 5.7% at the end of December, and that's over 7% lower than we saw during the Millennium Drought. Now, the storage volumes in the southern basin were much higher relative to the north and didn't reach the lows we saw during the Millennium Drought. Although the southern basin did experience 3 years of below average winter rainfall between 2017 and 2019. So how did low storage volumes in the north affect communities and water-dependent businesses? For an irrigated farmer, drought is often felt through low water allocations, which stem from low inflows to rivers and dams, usually over several seasons. One wet year may provide enough water to grow crops over more than one season. However, once a dam gets low, it can take large amounts of rainfall over consecutive events to fill them again, meaning the journey out of a drought can take some time. As you can see on the left, the years between filling events years between filling events isn't particularly rare in the Namoi River Valley, where the Keepit Dam is only filled in 3 of the past 10 years, in 2010-11, 2011-12, and 2016-17. In the last 2 years, the monthly runoff in the Namoi River Valley has been well below average and was only 30% of the long-term average in 2018 and only 20% in 2019. This resulted in the major storages in the Namoi, which are the Keepit and the Split Rock dams, being at critically low levels, and a reduction of access to water in order to preserve supplies for critical needs. Farmers in the lower Namoi River Valley received 0 general security allocation on the opening day of the water year, which is the 1st of July, in each of the 3 years since 2017. To help basin communities understand water availability and make decisions about the use of water, the Bureau now provides fortnightly water reporting summaries. These help to improve the transparency of water management in the Bureau and will help communities to understand just how much water is available for irrigators, for communities, and for the environment. Now, the ongoing dry conditions had a significant impact on rivers. The map on the left shows the average daily river flows in December 2019, and it shows that most of the rivers in the northern basin ran dry. While this isn't that unusual for some of the ephemeral rivers in the northwest, it represents the lowest December flows on record, which is since 1980, for many of the rivers in the northeast that drain off the western slopes of the Great Dividing Range. And this is where the majority of inflows to major storages and the Darling River come from. As you can see, there were still some minor flows running through the upper reaches of the Namoi, Macquarie, Gwydir, and Border rivers, likely because of releases from storages, but none of these minor flows made it to the lower sections of the river, of the rivers, or into the Darling River. The map on the right shows daily streamflow deciles for December 2019, and it shows that streamflows were average to the lowest on record during December, right across the Murray-Darling Basin. However, while the southern basin was below average, it didn't reach the same critical levels as we saw in the north. And if we look below the surface to groundwater resources, we see a similar story, but this dry period comes at the end of a more significant long-term trend. The map on the left shows the location of bores in alluvial aquifers with long-term regular readings. They're shallow systems near the surface, which are more impacted by rainfall and other climate conditions. The map shows that there are a high number of bores, particularly in the north, that have the lowest levels on record. Now, this is based on a groundwater peaks assessment that was undertaken in June last year, and it will be undertaken again in June this year. If you look at the 2 figures on the right, these are representative of what we're seeing in groundwater in the north and the south of the basin. Groundwater levels in the Gwydir and the Murrumbidgee show a similar pattern, which is common in the Murray-Darling Basin. Prior to the 2000s, there was less development in the region, and we didn't see as dramatic changes in groundwater levels. During the Millennium Drought, which is highlighted, levels decreased overall, and we also saw lower troughs during the year. If we look at the recent drought, we can see there's been similar decreases during the last 18 months, and levels during this time were as low or lower than we saw during the Millennium Drought. And we can also see that the southern basin tends to be less impacted than the north. So I want to close out this section just by returning to the theme of the first slide. The last 3 years to December was hotter and drier than ever. And this had a significant impact on water resources. Soil moisture was the lowest on record in some areas, affecting the viability of dryland farming. Water storages in the north reached levels unseen during the Millennium Drought, limiting water available to irrigators and communities, and with flow-on effects to small businesses. Rivers ran dry, affecting town water supplies and wildlife, and groundwater levels continued their decline to levels lower than we saw during the Millennium Drought. So 2017 to 19 was hotter and drier than ever before in the basin. In 2019, was also the hottest year on record for Australia. So now that we've seen just how dry it got in 3 years, we're going to see how much relief recent rainfall has brought to water resources in the basin. But I think before we go to that, Jordan, do we have another question?
Yep, we do. We also have a great poll that we'd like to get to as well. It's a great start by you, Daniel. Really enjoyed that. How much of Australia's irrigated produce is from the Murray-Darling Basin? That is our poll question today. You should see it on the right. We have A, 9%, B, 26%, C, 50%, and D, 98%. So please click whichever one you believe it is. And a little additional fact, or maybe a little hint, is that this is worth around $7.1 billion a year. That is a lot of money. We do have some great questions coming in. David, he would like to know, do hydrologists measure or take into consideration the change in underground water levels in the Great Artesian Basin?
In the groundwater levels we looked at in the last slide, they're looking at shallow aquifers, and they're typically not connected to the deeper groundwater resources of the Great Artesian Basin. So we do take that into account, but they're less connected there's less connection to shallow aquifers that are used in the basin.
Okay. Well, we still have plenty of time for questions as well. So if you have one, and especially if there's one specific to hydrologists, you've got two of the best right here. Sarah would like to know, do you consider groundwater process in modelling the saturation of a catchment?
I think I can answer that, Jordan. There is a groundwater element in the modelling that we use for the soil moisture in the catchments. We model deep drainage. We tend to rely on it more in areas where we don't have a detailed groundwater model that the states provide information on, and it tends to slightly underestimate the recharge into the groundwater. But yes, we do model that in terms of the saturation of the catchment. There is water that moves from the soil to the groundwater in that.
Okay. We've also got a question through that says the map of groundwater borehole levels shows many boreholes in Victoria around the Murray River area, with some bores showing very much below levels, in close proximity to other bores which show very much above average levels. Do you have any idea what might cause this strong variation across such a small area?
I might have to refer you to one of our groundwater specialists on that. I do know that pumping in groundwater can draw down very locally. So our groundwater hydrologists do make an assessment when we're choosing to look at a bore and a representation of an area. They will make an assessment as to whether they think it represents an area or whether it is more of a localised effect. But if you send us an email at water@bom.gov.au, I can get a groundwater hydrologist to specifically get back to you.
Okay, yeah, that email, water@bom.gov.au, if you have any other questions that might be a little bit too hard to do off the top of your head for these two guys. Norm, is there a list of weather stations measuring rainfall and the best reflect each Murray-Darling Basement Dam catchment area?
That's a really good question. We have on the Bureau's website on the climate area, so bom.gov.au//climate, we have a whole range of information about recent observations and past observations. And we also have specific rainfall and river level conditions as well. I'm not sure of any that would be specifically the best to use to refer to inflows or rainfall in a certain area, but if you go on the Bureau's website, you can certainly look at the rainfall data that we have available, for right across the country.
I might just add to that, Jordan, if that's all right. On the Landscape Water Balance website, which is on the Bureau, so that's just the bom.gov.au/landscape, you can get the gridded average rainfall for a catchment. So if you click on there, they're the larger catchments, so kind of like the river regions of Murrumbidgee, Lachlan, those sort of things. But you can click on that and it'll take an average of the whole catchment and give you a time series of how it tracks across time. So you can need that gridded rainfall is based on the station data, but it will give you a location anywhere in Australia.
Okay. I might just squeeze one in before we get to our results as well, because I feel like if we're talking about where we can find things on the website, this might be a good opportunity to ask this question from Sarah. Does BOM collect information on evaporation rates from public or government-owned storages? And if so, where can you find that data?
Yeah, that data is, oh, sorry, do you want to go, Dan?
I was going to say we do provide information on a range of different types of determining evapotranspiration rates on the through the Australian Landscape Water Balance Model. So on the Bureau's website, if you search for the Australian Landscape Water Balance Model, you can look at actual and relative evapotranspiration rates for areas across the whole of the country. And I would expect, and maybe Alison can confirm this, that we do include observations from water authorities around the country.
Okay. Well, I think before we start this webinar, we were all thinking of different ways to do some warm-ups, and I think I have a new warm-up word, evapotranspiration. If you say that 10 times fast, I think you'll be ready to go. We've got our poll results in now, how much of Australia's irrigated produce is from the Murray-Darling Basin, and more people said C, 50%. Guys, I don't have all the answers here. Can you enlighten us on what the answer is?
Yeah, it is 50%. So we have quite a well-informed audience out there.
And I'm sure a lot of people from the Murray-Darling Basin are very proud. We're getting that information coming through with the questions. Thank you so much for your questions, and we'll have another Q&A session coming up towards the end of the webinar. Right now, though, Alison, you're going to talk about the recent rains.
Yeah, thanks, Jordan. Oh, there we go. So, yeah, I get the exciting part of this webinar, maybe, where I get to tell the good news stories of some of this rain since January. So if we look at it, how it occurred, how it played out, we can see that it was pretty dry until mid-January when the first rain arrived, particularly in the north. So areas around Moree and Toowoomba in January received upwards of 100 millimetres for the month. It was only really enough to wet the landscape, though. It was only, as you can see on the right here of the decile map. So this is a millimetres of rain in the month, and this is a decile for the month. So this gives us a sense of, compared to January's in the past. We can see that it barely got above average in these areas, even though it was quite significant falls compared to what we'd seen over the last 3 years. If we move on into February, we can see that some of these northern areas got some really valuable follow-up rain. And so with the landscape already wetted by a little bit of rain in January, we did start to see some of the rivers flow through the border rivers area, and particularly up through this Condamine-Boulogne catchment up through here. Around St George, I think they got over 100 millimetres in only one day in the middle of February. So I'll talk a little bit more about the water, what happened to that water up in the Condamine-Boulogne in a few slides' time. So this rain was significant. It registered to very much above average to highest on record as it came through. But again, it was very much focused in the north, down through New South Wales. By February, still hadn't really received any significant falls and remained very dry at this point. When we moved through to March, this rain did start to move south. So we saw some valuable falls through the Macquarie catchment and even through the Lachlan and Murrumbidgee. And this started to show up in the deciles too. We saw very much above average rainfall falling right out into the western Murray-Darling Basin to this lower Peru, where we saw some flows come through there as well. But it wasn't until April that we really saw it move into the south. So this is where we started seeing rain right down through the east of the basin, where Dan talked about a lot of the flow from the Murray-Darling Basin and the fill of the storages comes through, and then into this lower Great Dividing Range, where a lot of the big storages of the Southern Basin are. So we have Dartmouth, Hume and Eildon, which have a capacity greater than the whole, twice as much as the whole Northern Basin put together. So when we get rain in this area, it's really valuable for our water availability, at least for the Southern Basin. And as you can see, by this stage, the rainfall through New South Wales was pushing very much above average to highest on record right through down into Victoria. So across this whole period of January to April, we got above average rainfall for these 4 months right across the basin. And we got upwards of sort of up to almost 800 mil down in this area, but most of the basin got in the order of 50 mil, upwards of 50 mil, and then through this valuable eastern side, got between sort of 300 to 400 mil, which proved really valuable to our soil moisture across the basin. So on the left here, we have a map of the soil moisture in April, so where we got to by the end of that period with that rain. And on the right, we have how much the soil moisture changed in percentage of available water content from the end of December to the end of April. So you can see that we reached above average levels of soil moisture. This is surface soil moisture, so top 100 centimetres of the soil, the root zone soil moisture that Dan was talking about earlier. So you can see that right across the basin we received enough rain to push the soil moisture to above average. It was still, didn't get a lot of rain in this far western section, but certainly through New South Wales by the end of April, we'd seen some changes of up to 50% in available water content. So this bodes well for the beginning of the dryland cropping winter season. If we can keep a little bit more rain coming and feeding those crops, we should see a good season come out of here. Although, as we know, this takes some time to come to fruition. So these farmers, while they'll get it growing, they might take till spring before they really see any benefits from it. So if we move on to the impact on the streams, on the left is just the map that Dan showed earlier, just to remind you the situation in December, where a lot of these northern rivers were completely dry. And on the right here is where we got to by the end of April. So you can see that as the rain dropped off a bit in April up in the north, some of these higher tributaries have started to dry out again, which is not that uncommon for these ephemeral streams, which is streams that will come in floods and then they spend long periods dry. But what was fantastic was that we saw these flows come right down through the Darling system here, down past the Menindee Lakes and even down into the Murray, which I'll talk a little bit more about how that event occurred. If we look at this in terms of how significant it was, so this is the situation again in December, we've seen some very much above average flows in April down through the Macquarie catchments, and while it started to drop off a little bit through these border rivers, we're still seeing flows in these rivers making their way down the system. In the Southern Basin, we've just come to the end of the irrigation season, so the bulk releases have stopped from the big storages. So the rivers are just looking pretty average, but they'll come into their filling season through the winter. So we'll hope to see those numbers boost over the coming months. But what we're really talking about here, when we're talking about a whole lot of dots on the map, is these rivers are starting to flow and the joy that that's bringing to the local communities, the wildlife. This is a picture of Jack Taylor Weir near St George. So this received that really high rainfall event in mid-February. And yeah, as you can see, the gates are up and they're letting this water rush right down through the lower Balonne. So if we have a little look at a really good news story of where that water actually ended up, the rain that came from the rain up around St George and further up in the Condamine Balonne. One of the great beneficiaries of that rain was the Narran Wetlands. So the Narran Wetlands is in New South Wales, just over the border in the lower Balonne catchment. And it's a Ramsar wetland and it's home to migratory birds, and it has local Indigenous people. It's a very significant cultural site for them. And it hadn't had a drink for over 7 years. As you can see here, this is a photo of what it was like before the rain came. And the Condamine Blown was particularly heavily hit at the end of 2019, having the lowest rainfall on record for 2019 by like 50 millimetres, which is pretty extraordinary considering the catchment average is only 170 millimetres. So, you know, to lose 50 centimetres for the year, 50 millimetres for the year, sorry, is a pretty significant loss for this area. So it was very dry. Then that rain came in February that made it down through the system, through that through this Beardmore storage, which is this picture here. So it came down the Condamine, filled this Beardmore storage within 8 days, and then kept flowing down through that Jack Taylor Weir that we saw. It then came down the Narran wetlands, and as you can see in these flatter northern catchments, the rivers don't stay in their channels. They flow right out across the floodplains when they flood, and you can see it's really spread out across the landscape here, but made it down into the Narran wetlands here, and you can see it went from this just dust bowl to this beautiful lake that's now starting to feed the wildlife. Another good news story from these rains has been the river flow that's made it down the Darling River. So the flow, this graph represents the flow past the gauging stations that are represented over here. So number 1 is here. So it started right up at Walgett on the Barwon. The flow came down the Kalgoa and in through the Namoy as well, but we're just going to start with the flow from the Barwon that came down past Burke and then through to Wilcannia. And as you can see, the peaks remain quite high through this system because we're getting inflows from the other tributaries, but there were huge losses with water soaking into waterholes and dry riverbeds, but it was topped up enough by those tributaries to continue down the Darling. This big gap here between Wilcannia and Menindee was the filling of the Menindee lakes. A couple of the lakes, which I'll show you in a minute, have filled. And so they took some time to fill that, and then they started releasing out of them to the lower Darling, past Menindee, and then all the way down to Wentworth. By mid-April, it reached the Darling. It reached the Murray River confluence and is now flowing down. And ideally, some of that water will make it all the way down to the mouth of the Murray in South Australia. Okay, so they were the sort of 2 good news stories coming out of this rain. We've got good soil moisture. Some of the rivers are at least temporarily flowing, but unfortunately, we didn't see the increases in the water storages that we would like to have, or they just take a lot longer to respond. So the soil soaks up a lot of the water, then it runs off into the rivers, and then we'll get flow into the storages. So on the left here is a map of the storages that you saw earlier that Daniel showed, and this represents the change in storage from December to April. So we've seen changes of about 10% across those storages, and in the Northern Basin this is equated to about a 10% or 12% change in the total storage in the Northern Basin. So this is not a huge change. It's definitely a step in the right direction and there's relief some of that high security allocation pressure, but there's a long way to go when it comes to the storages. The storages in the south, as we said, they've just finished release, a long period of release in the summer, and they'll come into filling season now. But the really good news story is the Menindee Lakes. So the Menindee Lakes is a series of lakes. So at the moment, we only report on 4 of them because they're the ones that are larger than 1 gigalitre, as Dan mentioned earlier. But the Wetherall and Hameroo are the ones that have filled on our registry. And there's about nearly 300 gigalitres of water in there, and Water New South Wales estimate that that's about 12 months water supply, town water supply. So these levels are expected to continue to rise with further flow down the Darling. So at least there's some, they've gone from 0 to 89%. That's the Lake Wetherall in only a couple of months. So that's a really valuable addition to the basin at this point. So just to summarise on that, we've only reached sort of less than 20% across most of those northern storages, except for this is that Beardmore storage, and then down through the Menindee Lakes. So by the end of April, we haven't made a huge dent into the water storage availability. Another way of looking at how much difference this rain made was to look at the rainfall deficiencies. So the rainfall deficiencies essentially represent the water missing from the system over the last 3 years, and this is that map Daniel presented earlier, where you get lowest on record for the past 3 years. So one way of looking at it is, if we were to return this map to light pink, so just below average across the basin for the 3-year period, how much water would it take to get us to that 10th percentile? And so that's what we've modelled here. Over the last 4 months, we would have needed this amount of rain. And so that equates to about sort of upwards of 600 millimetres in places like Tamworth and in the Namoi. And this is the rain that we got. So as you can see, it was significant, but we still had a long way to go. We needed upwards of 600. We sort of got upwards of 300 or 400 in through this area, for example. So this is left, and what we needed was highest on record or exceeding highest on record through particularly this very dry area of northern New South Wales. We got some good rain, but not enough to relieve these deficiencies, not enough to replace the water that's been missing over the last 3 years. So this is the situation we've been left with at the end of April. We're still seeing below average rainfall for the 3-year, 4-month period across most of the basin, which can reflect, like I say, the amount of water that's missing over that period, but also the amount of time that the people in the basin have been experiencing this dry weather, and the magnitude of rain that's going to be required over a longer period to relieve their experiences. So, for example, just in a water resource perspective, if we would need 2 years of 50%, 2 years of average rainfall to fill the Copeton Dam, which is up here, to 50%, and to get it to 80%, we would need 3 years, over almost 4 months, almost 4 years of average rainfall. And that's just average. If we continue to get these months of dropping below average, those storages are going to take a long time to fill. In the Split Rock, which is near Keepit that Dan spoke about earlier, it can fill very quickly, but if we look at it on an average scale, we're looking at nearly 3 years to get it to 50%. So let's hope that we get some significant rain in the coming months, and let's have a quick look at that. So we're just going to have a little look at the outlook for the coming months, because there is another webinar coming up on the 4th of June that will take a closer look at the winter outlook for the Murray-Darling Basin in Australia more generally. But these are really great looking maps. We've been looking at very red outlook rainfall maps for a very long time. This time last year, all of this area is red, and now this blue area represents a greater than 80% chance of above average rainfall over June to August. Now if you look at the individual months, which they will go through, and you can look at it on the Bureau's website down here, this rain is expected to come a little later in the season, but we're looking at above average rainfall right from the start of June. In terms of temperature, what often happens when we get rainfall is that we don't get those clear cold nights. So when looking at above average temperatures, minimum temperatures across the basin, and the maximum temperatures are likely to be pretty close to average, maybe even a little bit below average, which is quite different to what we were looking at this time last year. And that brings us to the end. Jordan, if you want to ask a few more questions, if people have got them.
Yeah, we do have plenty of questions that have come in, and we'll try to get to as many as we can. But just on your last point there, that webinar that we will be hosting on the 4th of June with all that information, a link will be coming up in chat in just a minute, so you can click through and register now. I hope that's given your business a lot of information you can use to plan for the upcoming months. But let's jump into some questions. Catherine, she wants to know, did any critical streams miss out completely on the good falls in January or April? January to April, excuse me.
Yeah, none of the major rivers did. They all received good rain somewhere in that January to April period. That's the area that I pointed to in the far west in South Australia. They have not received a lot of rainfall, but not many of them are major rivers that flow into the system. There could be some creeks over in that area that have not flowed this year, but all of the major rivers received enough rainfall to flow this year.
Okay. We have received a couple of a couple of questions about groundwater information. And just there is an email that you can sign up to as well on our website about groundwater. But Patrick, I'd like to know, can you please let us know where we can find groundwater peak assessments from June 2019? Is that somewhere on the website?
The groundwater peaks assessment report, stand by. Sorry, I was trying to remember where it is. So we have a peaks assessment report for 2018 and 2018 to 2019, and the 2019 to 20 will be undertaken in June of this year. And you can also find more detail on Groundwater Insight, which is one of the groundwater tools we have. But I'm sure if you either Google for groundwater peak assessment for that report, or get in touch with us at Water at BOM, then we can provide you with a copy of that groundwater peaks report.
Okay. And as he was thinking there, you can definitely tell if that doesn't prove that this is a live webinar, I don't know what will. We've also got a question, another question about groundwater. Does groundwater recharge occur generally over the region, or are there specific locations where higher recharge could occur?
Yeah, so it depends on what it's recharging. So groundwater can exist at multiple levels within the soil, as most people would know. But so the deeper aquifers, they have particular areas where they recharge more than others. But the shallow aquifers, it tends to be a bit more uniform. But if you go to that Groundwater Insight, it'll give you a indication of where the shallower aquifers are and where are the deeper ones, and it shows where our recharge zones are.
Okay. Michael would like to know, does the extended periods of drought affect the ability of precipitated water to filter into soil and help alleviate low water tables?
I think it can do. I'm not particular expert on this topic, but I know that when you have like very low soil moisture conditions, can actually lead to a little bit of a crust on the top of the soil, and that can prevent, like when rain does fall, it can actually make it run off rather than infiltrating into the soil profile. So very dry conditions can almost sort of self-perpetuate, where when rain does fall, it doesn't actually enter the soil profile.
Okay. Jane would like to know, how accurate is water accounting regarding groundwater and aquifer recharge? Excuse me.
Yeah, I can answer that. So groundwater accounting in our national water account is done by a combination of quite detailed groundwater models that are provided by our state agencies. And so they do that modelling with their local knowledge and provide us the information to be able to summarise it across the country. And in areas where there's not groundwater specific models, we use what we talked about earlier, where it's the recharge that comes out of the soil from the AURA modelling, so the Australian Water Resource Assessment Model. And that does tend to underestimate the recharge slightly, but it gives you an indication of what it does across the whole country rather than just where those groundwater models are.
Mark would like to know a little bit more information on the interconnection between surface aquifer recharging and the river's hydrology.
Yeah, I mean, that's a really great question in terms of the drought as well, because that interconnection between the surface water and the groundwater has been quite severely affected by the drought in some areas. So In most cases, the groundwater would exist, well, in a lot of cases, the groundwater exists above the stream flow. So the groundwater provides a base flow to the stream flow. That's the interaction. But in some areas that we've looked at, particularly down in the south, some of that groundwater has actually fallen below the stream flow level. So now that river is actually losing water to the groundwater rather than having it provide a base flow. So that interaction can change with the changing conditions, and it can it can exacerbate the influence of the drought on that surface water. We're not seeing that too widespread, but in areas that it does occur, it can draw down the surface water quite quickly.
Okay. Claire has a bit of a climate question. She'd like to know, what was the cause of this most recent drought, and is it the same cause as the Millennium Drought?
I think one of the main causes of the most recent drought was a very, very high, I think highest on record, Indian Ocean dipole. So the Indian Ocean dipole is a temperature variation in the Indian Ocean that affects rainfall in the southeast of Australia. And towards the end of last year, we had a very high positive Indian Ocean dipole, and then the outcome of that was very hot and very dry conditions across particularly the southeast. Maybe Alison can talk to more about the drivers for the Millennium Drought, but I would have thought that was driven a bit more by El Nino than by the IOD.
Yeah, that's right, Daniel. So the Millennium Drought was much more driven by El Nino. So that's the sea surface temperatures across the Pacific rather than the Indian Ocean. But as hydrologists, we deal with more of the water once it hits the ground. So the climate guys would probably be better to talk to that if you want to send us an email.
Okay. Yep, send the email and we'll try and get that answered for you. Nicholas would like to know, are the catchment areas sufficiently wet that any follow-up rains over winter and spring will flow into storages rather than being absorbed into the ground?
Yeah, that's a great one. I should have mentioned that a little earlier. That is exactly the position we're in at the moment, where a lot of those key storage catchments are quite wet, starting to dry a little bit up through Queensland, but they're quite wet and they are well primed for further rain to run off into those storages. And to some degree, a lot of those smaller streams that run into the storages, they've got some water in them too. So we are in a great position to get follow-up rain and inflow into those storages at this point.
Okay. And we might have touched on this earlier, but Sarah, she would like to know about evaporation losses. Where can she find more information on that?
Sarah can find more information on evaporation losses on the Bureau's website, on the Australian Landscape Water Balance page. And there's also evapotranspiration information on the Bureau's climate pages. So I think if you can certainly find it in a number of places. So if you go to our website, do a search. If you need some more specific direction, then we can get in touch and we can help you out.
And the water area the water section of the website has so much information there. And also we've got that email, water@bom.gov.au, that you can send us. So we're getting into our last questions now. Mike, what has the recent rainfall done to storage levels in the Darling River catchment?
Yeah, so I spoke a little bit about that in that second last slide. So we've seen increases of about 10% in most of those upper Darling tributary storages, except for through that Condamine Blonde, where we've just seen that skyrocket to 100%. So it's not a lot, to be honest, particularly through the Darling catchment. 10% from the critical low points that they reached. We need some follow-up rain in the coming months, and hopefully that outlook comes to fruition and we get that. Now the storage catchments are so well primed for it, but yeah, the impact of the rain did great things for most of the soil and some of the rivers, but the storages really haven't got the inflows they need yet.
Okay. And Martin's kind of, I think might be the best question to finish up on, because he's trying to wrap it up into one big bow. Any idea how much recharge this will lead to?
Recharge of the groundwater. That's a good question. Given that we filled the soil sponge, how much will make it down into the groundwater to recharge? I don't think we can answer that question yet. Groundwater is a little bit slower to react than the surface water, and it'll be a matter of looking at the recovery over the next couple of months to see how much recovery we actually get from this rain in the groundwater recharge.
Okay. Well, so much information there. I really hope you got as much out of it as I did. I love learning about this kind of stuff, but a lot of information to take in there. If you did miss the start, Daniel, would you like to summarize what we spoke about today and where people can find more information?
Absolutely. I think that the main take-home message that from our talk today is that we've had 3 very, very hot and dry years in the Murray-Darling Basin. This has had a significant impact on the availability of water in a variety of sources through groundwater, soil moisture, and water storages. And what we've had recently is 3 or 4 months of above average rainfall, and it's helped, and it's certainly helped soil moisture. But I think we need a number of months of above average rainfall to even start making a proper dent, certainly in terms of water storages in the north, to make a proper dent into what we've seen over the last 3 years. And in the south, we're coming into the winter filling season. So we'll probably see storages in the south increase. But in the north, we tend to see water storages increasing over summer. So we're coming to the end of summer, so we might be looking at another period where we don't have significant recharge of the water storages in the northern basin. And in terms of where we can find more information, we have monthly drought statements and a really good special climate statement. So if you Google for the Bureau's special climate statement, then that will give you all the information, mostly that we've spoken about today. We also provide water reporting summaries that provide for each of the major drainage divisions across the country, provides a summary of rainfall, stream flow, salinity, and storages. We've mentioned the Australian Landscape Water Balance website or page on our website, and that has information on runoff, soil moisture, evapotranspiration, and a bunch of other information. And by all means, if we haven't answered any of your questions, then please send us an email at water@BOM, and we'll do our best to get back to you.
Excellent. Well, a lot of information in there and a lot of different resources people can get to. If you miss some of those links, with our email, we do send out a copy of this presentation, so you can just click on the link through there as well. Our next BOM webinar, as Alison talked about a little bit earlier, is on June 4 and is focused on our winter 2020 climate and water update. This is one of our 4-season webinars we run every year, and it's really popular. So if you'd like to come along, please click the registration link that is now in the chat so you can join us. That brings us to the end of our webinar today. For any questions we didn't get to, please email water@bom.gov.au. A big thank you to Alison and Daniel and your time in developing the content and sharing your knowledge with us. And to you, thank you for tuning in and joining us today. We hope you enjoyed the session, and we do hope you'll join us again next time. If you'd like to continue the conversation, please use the hashtag BOMwebinars in your LinkedIn posts. As mentioned earlier, the session has been recorded, and we will have the video ready for your on-demand viewing pleasure in the next couple of days. So please watch this space and your inboxes. Finally, but most importantly, we want your feedback. It's our aim to bring you the highest possible quality webinars, but we can't do that unless you share your experiences with us. So once we close this webinar, a short survey will pop up on your screen, and we'd be really grateful if you could complete that anonymously for us. Once again, thank you for your time, and we look forward to seeing you again soon. Goodbye.
Bye.
Thanks, everyone.